So good day everyone, my name is Villafuerte of CPE 2CC3. So this is my programming assignment, the Doubly linked list. So these are the things that I import so that the user can input in my program. And static buffered reader, in is equals new buffered reader, new input stream reader. So the new buffered reader and new input stream reader is being inputted at in. Then static Villafuerte doubly linked list equals new Villafuerte underscore doubly linked list. So the new Villafuerte underscore doubly linked list is being inputted here in the doubly linked list. Then this is my main method, by the way. So here the user will input the total number of employee. Then in total equals integer that parse in that read line here. After the user inputs here, the input of the user will be located here at the total. Then employee record total, call this method and pass the value of total. So here private static void employee record in total throws number format exception, IO exception. So the user will input the tax rate here. Then in tax underscore rate equals integer that parse in that read line. Here is the here where when the user is done inputting the tax rate, the tax rate is located here, is saved here at the tax underscore rate. Then int I equals to 1, so we use the while loop. If I is less than or equal to total, so here the user will input the ID, the name, the rate per hour, numbers of hours worked. And then these are my formula. These are the formulas of getting the gross salary, the deduction, and the net salary. So in getting the gross salary, rate per hour times number of hours worked. Then in getting the deduction, tax underscore rate divided by 100 times the gross salary, which is the result of this one. Then the net salary, in order to get the net salary, we need to subtract the gross salary and the deduction. So in post equals to find post ID. This method is called to find the position to the new inputted employee's record. So doubly linked list dot insert at post ID, name, rate per hour, num hours worked, gross salary and net salary, and post. After the method find post executed above, this method will insert the data to the doubly linked list with its assigned position. Then it increments it. Then menu to choose tax underscore rate. This method is called and let the user to choose the following here. So here the user will choose A, add an employee record, B, delete an employee record, C, display all employee record, D, display the employee record with the highest net salary, E, display the employee record with the lowest net salary, and F, exit. So now we use the switch case break keywords. If the user will choose A, so add employee record. This method will be explained later on. Then if P, delete employee record, then this is the method to delete the employee record. C, display all the employee records. So this is the method to display the employee record, so I'll explain that later. Then D, employee with the highest net salary. This is the method in finding the highest net salary, which will be explained for me later, and which will be explained by me later. Then if E, employee with the lowest net salary. So this is the this is still the method in finding the lowest net salary, and F is break. We exited the list. So here, this is the method of adding the new employee record. So the user inputs here still the number of employees he or she wants to add. So just the same as earlier, in total is equals to integer that parse in that read line. So just like that. Then in finding the position of the ID, this will find in this method this will find the position of a new employee record in the list. So in I is equals to 0, if doubly linked list that size is equals to 0, or the head of the ID is greater than the ID value, then the I is equals to 1. Else, if the node F is equals to doubly linked list that head, so F is equals to F dot next, I is equals to 2, and while F is not equals to null, if F dot ID is greater than the ID value, so break, else it increments. So this is the method for deleting the employee record. So this method will let the user to delete employee record with a valid input ID number. So here the user will input the ID number he or she wants to delete. So node temp is equals to doubly linked list that head. The temp pointer is point to the head node so that it will scan from the start. While temp is not equals to null, while temp is not pointing to null, the while loop is not terminated. If temp.id is equals to emp_id, this condition will compare the user's input if it is in the list. So if it is in the list, doubly linked list dot delete at position I if the condition above is true, so therefore the current position will be deleted. Then break, else I++, this I is used for the position to delete. Then temp is equals to temp dot next, this will point to the next node. And if temp is equals to null, this means that the ID inputted by the user does not exist in the list. Now here, this is the method in finding the employee with the highest net salary. So this is the method. Note that temp is equals to doubly linked list that head, double hold is equals to underscore net salary is equals to temp dot net salary. Temp is equals to temp dot next, while temp is not equals to null. So this method will execute if the temp is not equals to null. If hold underscore net salary is less than temp dot net salary, so hold underscore net salary is equals to temp dot net salary, and temp is equals to temp dot next. Temp is equals to doubly linked list dot head system dot out dot println. So it prints all the records of the employee with highest salary here. Now here is the method on finding the lowest net salary. This method will find the employee with the lowest net salary. Then node temp is equals to doubly linked list dot head. The temp pointer is point to the head node. Double hold underscore net salary is equals to temp dot net salary. Temp is equals to temp dot next. While temp is not equals to null, this will be executed like here in the highest net salary. So this will be executed, then in here it will print all the records of the employee with the lowest net salary here. Then next, this is my node.java. So string name, double rate per hour, gross salary, net salary, int ID, numbers are correct, node previous and node next. So public node int d, string na, double r, int num, double g, double net. Then id is equals to d, name is equals to na, rate per hour is equals to r, num hours work is equals to num, gross salary is equals to g, net salary is equals to net, next is equals to null, and prev is equals to null. So now this is my doubly linked list. This is where we can find the doubly linked list method in insertion, insert at start, insert at end, delete at position, delete at end, and delete at start, and the display of letter C, display of the employee record. So here we declare here node head, node tail, in is size, we declare size or number of nodes inserted. Then here head is equals to null, tail is equals to null, size is equals to 0. So public void insert at pos int d string na, double r, int num, double g, double net, int pos. This method will allow the user to insert at any position. Then node n is equals to new node d na r num g net. So in this one, the d na r num g net, we find it in the node.java, like this one, d na r num g net. We declared it here. So now the if statement, if else statement, if position is greater than size plus 1, so system.out println position is not available. Else if position is equals to null, then this will be executed if head is equals to null, and that prev is equals to null, and that next equals to null, head is equals to n, and tail is equals to n. Else head that prev is equals to n, and that next equals to head is equals to n, head that prev is equals to null. Then else if position is equals to size plus 1, if head is equals to null, and that prev equals null, and that next equals to null, head is equals to n, and tail is equals to n. Then else if n that prev is equals to tail that next equals to n, tail is equals to n, and tail that next equals to null. So else if node temp is equals to head, then temp is equals to temp dot next. Then now we use the for loop. For integer I is equals to 2, I is less than or equal to the size, then I will increment. So if I is equals to position, and that next equals to temp, and that prev is equals to temp dot prev that next equals to n, then temp dot prev is equals to n, then temp is equals to temp dot next, then size will increment. So here in insertion at the start, so this is, we see this at the node.java, new node is equal n equals new node d na r num g net, still at the node.java. So the method here, if head is equals to null, and that prev is equals to null, and that next equals to null, head is equals to n, tail is equals to n. Else if head that prev is equals to n, and that next equals to head is equals to n, head that prev is equals to null, then size will increment. Now here in inserting at the end, so this one we see this in the node.java, and this one so excuse me, if head is equals to null, this will be executed still like before, and that prev is equals to null, and that next equals to null, head is equals to n, tail is equals to n. Else and that prev is equals to tail that next equals to n, tail is equals to n, tail that next equals to null, then size will increment. Now here it will allows the user to delete at any position. If position is greater than size, so this will be print position does not exist. Else Else, if the position is equals to 1, when the user inputs a position 1, it will delete at start. Else, if position is equals to size, this will execute if the user inputted a position equal to size or last node, then delete and decrementing size because we are deleting a node. Here, else, this will execute if the user input is greater than 1 but less than to the size to the number of nodes. Then node temp is equals to head. This is declaring a new pointer and will be used below. Temp is equals to temp.next, point to the next node because we will delete an inner position, not the head and not the tail. So we use the for loop. For integer I is equals to 2, I is less than size, then I increments. If I is equals to position, node p is equals to temp.prev, node n is equals to temp.next, temp.next.prev is equals to p, then temp.prev.next equals to n, then size will decrement, then it will break, then temp is equals to temp.next. So here in deleting at the end, if size equals to null, head is equals to null, set head to null because there's no node to be pointed. Then tail is equals to null, set the tail to null because there's no node to be pointed, and the size is equals to 0 because there's no node. So here, else, tail is equals to tail.prev, set tail equal to the pointer of the previous pointer because we are deleting the last node. Tail.next equals to null, the next pointer which will point to the next node is equals to null because it is a tail. Then size will decrement. So that one, public void delete start. If size is equals to 1, if there is one node only, then head is equals to null. Set the head to null because there's no node to be pointed, and tail is equals to null because still there's no node to be pointed, and size equals to 0 because there's no node. Then else, this will execute if there's node available is greater than 1. Head is equals to head.next, set head to point to the next because we are deleting node 1. Head.prev equals to null, set head previous pointer to null because it is a head node. Then size decrementing size because we are deleting a node. So now here, this is if the case is letter C, displaying the employee record. So node temp is equals to head. So here now we print out all the employee record that is being inputted by the user. So this is all my assignment. So my name is Villafuerte of CP2CC3, and thanks for watching.